I think we should get started.
Hello. Am I audible, everyone?
Yes, we are audible.
Okay. So, how are you all, guys? Good evening.
Good evening. Good.
How are you doing, everyone?
Just running the issues.
Sorry.
Just
How are
implementing
you
issues.
doing all? Okay. So, you are waiting for the session
Yes.
uh, regarding quantum computing, right? So, without any delay, we can start the session. This session is totally interactive. So whatever the doubts you have, if you don't understand any concept or if you want to know more about the technology and what are the VLSI technologies you want to know, and regarding the career guidance, how you are looking to enter into the domain, and what are the best ways to enter into the domain, and how we can select any of the field in VLSI, and what are the different projects we can work. If you want to know any of these questions and all, you can ask whatever the doubts you have. Okay. And if you don't understand any concept, you always your doubts are always welcome. Okay. So this is totally interactive session where we can help for the freshers and we can clear all the doubts from your side. Okay. We'll just start in 5 seconds. Just give me just 5 seconds. Okay, so let me start. So I am audible to everyone, right?
Yes, madam.
Yes, you're audible.
Yes, ma'am.
Okay, fine. So hope you are all studying bachelor's or master's. And is there any working professionals here, like who are working in VLSA or some other domains?
Yes,
Yes,
madam.
ma'am. I
I am.
work in embedded
Okay,
software development.
okay.
I
Good.
am working in VLSI, madam.
Okay. Okay, so
Yes,
you are looking for more about the future technologies in VLSA, yeah?
yes, madam. Yes.
And I'm looking for transitioning into VLSI actually.
Okay. So even if you have any doubts regarding the embedded system to VLSI or non VLSI to VLSI, we can discuss further. Okay, at the end of the session. So quickly we can get into the session regarding the quantum computing, the future of VLSI. Okay, so this session is totally regarding how we are going to enter into the new technologies in VLSI, and what are the major drawbacks we are facing in the current technology, and what are the different type of fabrication technologies are using in current classical computers or supercomputers. Okay, so at what nanometer technology we are in currently, even whatever the mobile phones you are using, the laptops we are using, what current technology we are using, and what are the limitations we can face, and how we are going to overcome that, we are going to have the clarity. And also you already know we have launched the quantum computing course, right? So many of you have the confusion like what we are going to learn exactly from the quantum computing course. So I'm going to give the clarity about that course first, then we are going to discuss the detail about the future technologies in VLSI and what are the current limitations in VLSI. Okay, so everyone please mute. Whatever the doubts you have, if you have any doubts, so for more clarification, you can unmute your system and you can talk. Okay. Meanwhile, you can mute your systems. So coming to the first of all, let me introduce you about the ProV Logic, because ProV Logic is a new, it's an institution come service based company. So I think most of you not aware with ProV Logic. And so let me just give you a small introduction about it. Okay, so coming to the ProV Logic, our vision is to make the global ProV Logic as a global leader in VLSI training and services. We are empowering the students and working professionals to excel in the dynamic semiconductor industry field. Okay, so we are having the lot of collaborations with the industries and also colleges. We are providing the services to our best students and also who completed the training in ProV Logic regarding the VLSI. We are providing the best placement from the top product based companies and service based companies. Okay, so our mission is to deliver the high quality sessions that focus on areas where students are lagging in the meeting industry standards. Okay, because every college, if you see everywhere, the students doesn't have proper industry standard knowledge. Okay, whatever the industry is expecting from the student side, they doesn't have proper capability to understand the technical skills of VLSI, because VLSI is totally different where we don't learn anything in the college, right? In the college we just learn the academics like electronic subjects, and there will be some coding languages and some different subjects will be there. But whatever the industry is expecting deep into the core VLSI, we never find such subjects in the academics. Okay, due to that, the most of the students are lagging to crack any core job, even though we don't get much opportunities to the college, right? Because of the academic lagging, and also there will be no proper guidance at the college itself. Okay, so due to that, we are want to provide the more webinars to the students who are studying BTech, and to give them more awareness about the VLSA. That is our main motive. Okay. Next, coming to the ProV Logic, the founders are Prashanti Chanda and Vishwa Arya. Myself, I am Prashanti Chanda. I am expert in VLSI, driven mentor. From last 4 years, I have worked with the semi design. I have given the lectures nearly 3 to 4,000 students plus students from top institutions like NIT Trichy, IIT Delhi, IIT Madras, and local colleges, and also top universities. We have given the trainings, and also we got 90% placement record in the semi design. I'm also a passionate educator and a visionary leader. And coming to the Vishwa Arya, he is the co-founder and marketing strategist and visionary partner. And coming to myself, I am into the design verification in VLSI. Over the years, I have the expertise in system on chip design and debugging with a strong knowledge in RTL design and verification. I have the proficient knowledge in system Verilog and UVM methodologies. With that expertise, we have developed in a team like various VIPs and IP with different teams with American clients, and also in India. I have worked with the AMD and in semi technologies. Okay, so with this knowledge, I have the proven track record in the ASIC design and various IPs. And also, I am the passionate trainer, the dedicated trainer with a passion of mentoring the students. And also, the work experience, I have worked with the different companies like ASICS and Technology, which is a Novomind, the American client. And recently, I have worked with the AMD company, and then we founded the ProV Logic. Okay. So, coming to the today agenda, we are going to discuss about the importance of VLSI, what is meant by VLSI and VLSI technologies, and how the VLSI is there from through the ages. That means from last 100 years, 60 years, how the VLSI technology is growing in the industry, and what is Moore law and how it is impacted in VLSI, and what are the upcoming future technologies in the market we are going to see in the future, and if you are engineer, VLSI engineer, we definitely work on that future technologies. And also we are going to discuss about the VLSI design flow and the career opportunities, and how just I want to give you a roadmap on the tomorrow's technology. Okay. And about the quantum computing, the course, what is the 2-month course and how it will be helpful for the students. Okay. So this is totally interactive session. Whatever the doubts you have, you can discuss your doubts and you can clarify your doubts. Okay. Any doubts till here?
No, madam.
Okay, so first of all, getting into the quantum computing, I want to ask a few questions, whether you are aware with VLSI, the fabrication technology we are using currently, and what is the nanometer size we are using currently. I just want to ask some questions. Okay, you can just give the some detailed, just simple points explanation. Okay, so can you tell me, first of all, what is meant by VLSI, the chip design industry, how it works, and what are the daily applications we are seeing in chip design?
Hello.
Hello. Yeah. Guys,
Yeah,
can you please?
yeah, madam. Actually, VLSI very large scale scale integration chip. Actually, the actual present 3 nanometer I am working on.
Okay.
That is 1P 13 metal stack.
Okay.
Actually, I am working in physical design from floor plan to STA, post STA. I taken care like PNR, PV, STA, everything.
Okay.
Yeah.
Okay. That's great. Okay. Remaining freshers, do you have any idea about the VLSI and what are the present fabrication technology we are using? And what is the material we are using currently?
Present like fabric package and all flip chip technology is going on.
Okay.
Yeah, like that technology I heard, but recently one more technology they did in a paper research oriented, but that name I forgot actually. Their
Okay.
new package technology came,
Okay.
fabrication also, but I did not remember the exact word. It's,
Okay.
yeah.
Okay. Okay. Fine. Fine. So coming to the quantum computer, before quantum computer, let us discuss about the classical computer and supercomputer. Okay. So what is the difference between classical and supercomputer? You already know the
Yes,
computers mainly use the binary bits, either 0 or 1, based on the CMOS transistor technology and the Boolean algebra technology. Everything is Boolean logic only, right? Internal, whatever the instructions we are writing and the whatever the architecture we are generating, everything is developed from the basic digital logic circuits, and within the we'll have the lot of Boolean logic expressions. Okay, so in the classical computer, if you observe any processor or any chip design, like any system on chip design or ASIC chip designs, you will be finding some architecture like suppose there is a system on chip design. I think you may know about the system on chip design, where we integrate all different functional blocks in a single chip, right? It have the different type of components like a CPU. In the CPU, where it have some arithmetic logic and some control logic will be there in central processing unit. Like that, there will be a memory subsystem where we have different types of RAM, ROM memories, DDR, DMA controllers will be there, cache memories will be there. For storage purpose, there will be some HDD or SSD will be there. and the architecture will be related to the von Neumann architecture, which is a RISC processor related architecture or x86 related architecture. So, and there will be different types of IO peripherals, and the interaction will be done through serial or parallel data communication. Okay, so mainly we use these type of classical computers like in general purpose, like general purpose software development purpose, or in microcontrollers, or in embedded system related. We majorly use the classical computers, right? So what is meant by supercomputer? Supercomputer is also same as a classical computer, but bit more advanced. It is a high performance computing systems, mostly thousands or millions of classical cores. It will be used to perform the massive parallel computations. Okay, so supercomputers are very fast compared to the classical computers. Okay, classical computers even not SoC, those are like below the ASIC chips. But in supercomputers, whatever the technology wise, it is improving from FPGAs, ASICs to SoC, like that, where the CPU and GPU have the massive parallelism in cluster. We connect in terms of clusters. Okay, and also it will be having the network interconnects. Okay, like example, InfiniBand will be there, and it will be having lot of custom OS, and there will be different type of internal subsystem blocks will be interconnected. Okay, so where we use these type of supercomputers. Okay, but by using the classical computers and supercomputers, we are doing every application perfectly as of now. Okay, but if we go to the beyond, can you please mute? But if we observe the major, just a second. But if we observe the major applications where we cannot solve through the classical computers, we are having the future technology called quantum computing. First of all, let me explain you how the quantum computers are very powerful compared to the supercomputers. Okay, if you observe, like in 2019, that time, Google, the Google company, you already know the Google company, right? Google claimed that it can solve a problem, whatever it can take to solve a problem in 10,000 years. Okay, for the world's fastest supercomputer, which is a world's fastest supercomputer is there, it can solve a problem in 10,000 years. But it given the clarification that within just 200 seconds, a quantum computer can solve the same problem. The Google has claimed this. Okay, within whatever the problem statement it can do by a supercomputer in 10,000 years. Okay, the 10,000 years is equal to the 200 seconds by using the quantum computer. That is how a quantum computer work. It's a very, very billions times so faster than the supercomputer. Okay, so example, like another example, if we do a small task using a supercomputer in just 47 years or 50 years, okay, but same task a quantum computer can do in just 6 seconds. 47 years is equal to the 6 seconds. That is how the quantum computing technology will be, is going to evolve in the future semiconductor industry. Okay, but there are a lot of hurdles we need to come across, because there are a lot of limitations are there, disadvantages also there. We need to come across all the disadvantages, and then we need to crack this. Okay, but once the quantum computer is successful, the design, whatever the internal architecture we are using, whatever the internal design is successful, we can do billions of operations in just a single second. Okay, if you see, to build a supercomputer or a classical computer, we need to write lot of logical expressions. Internally, there will be complex functional blocks, and we need to define lot of blocks in a Boolean algebra or logic expressions. But by using the quantum computing, we no need to use that much of very complex hardware designs. That supercomputer hardware design is totally different. Quantum computer hardware design is totally different. Okay, so from the in this session we are going to discuss about the what are the present technology limitations and what is the importance of quantum computing importance. Okay, so if you are very interested, if you are at student level or if you are working professionals, if you want to learn more detailedly about the future technologies, okay, this quantum computing course will be most helpful. And that too, these all are live sessions, right? So you will be getting more interaction, and also you are going to clear your doubts in this session itself. You will be getting the lab session. We are going to use the lab sessions also, where we are providing the quantum composer IBM tool. Okay, so you will be getting working with the practicals, how this quantum computer is going to develop. Okay, let me explain you first of all what is the use of the like how the quantum computing course schedule we have designed, so that you will be getting the clarity, and whatever the doubts you have, you can discuss your doubts. Okay, so if you see here, the quantum computing in VLSI, it's not like a VLSI is a term like very large scale integrated circuit, but VLSI is not existing now. If we talk really, after VLSI we
Okay,
got
I
lot of
was,
technologies.
I
Hello.
have a doubting like whether we are dealing with anything related to the fabrication of quantum computer or a qubit.
No. Fabrication, how we do? Normal class supercomputers only. We don't have any fabrication technology here. How we do the quantum computing fabrication? Even it is not came to the market. It is still in a in a laboratory, just working on the technology.
I was asking like whether in this course we have any opportunity or anything we will learn about it or not. Like you have said like it is quantum computing in VLSI. The course name was like that. So I thought like there will be something about really fabrication or hardware, means anything related to the hardware of a quantum computer. So
No. It's not
my
related to the hardware of a quantum computing. Before going to the hardware of a quantum computing, you need to learn lot of things in the quantum. Directly, we cannot go to the hardware. It is just 2 months course. Okay. So before that, there are lot of things we need to make in observation, like how the technology is going to work really, the quantum principles, how the superposition principles and entanglement principles are really working. First of all, we need to work in the IBM composer. Once you got very good
So
clarity in
we are
the
only in this course. We are only just designing the qubit in the IBM Composer and how the qubits work or how the algorithms work.
yeah,
Whether
let
we are
me
dealing
explain
with the
entire
algorithms.
let me explain entire course curriculum. Then whatever the doubts you have regarding that, we can discuss. Okay, so first of all, we are going to start with the VLSI foundation. For another thing is, it's a freshers course who are studying BTech, MTech, and research. If you are doing the research, this course is entirely for freshers student. Okay, so if
Okay, I
you
am a
are doing,
student. I am also a fresher. I'm a student. That way I was asking the question very clear to
okay.
have a
So
clarity.
okay, fine. That's a good question actually. Before that, have you went through any fabrication technology for normal whatever we do nowadays on the wafer? Have you gone through the process, entire PD process, the manufacturing labs
No,
and all?
like I have studied about superconducting materials.
Uh-huh. Okay,
So
okay,
I was having I was a physics student. So I
okay.
have studied about the superconducting materials. So
Okay.
I want to know about like whether quantum computing means you to make a qubit. So I think that this course will help me to make a qubit like using the superconductor materials. That why I was interested in the
Okay.
course.
Okay. 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 Okay.
So they told
So
my
okay. Okay. Before that, do you have idea on physical design, how the entire PD flow will be happen, the manufacturing process? Do you have any idea on that?
uh, no, like VLSI technology, I don't have an idea.
Okay. 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 Fine. So actually in PD only we don't have the proper manufacturing labs as you are thinking. Okay, we have the labs like mostly in IIT Delhi or Madras, and even here in AMG also we don't have the fabrication labs. Okay, just a small setup, how the wafers are working, how we can dump some RTL netlist to the wafer, and how the placement routing these techniques will be working. That's a fabrication process actually, whatever you are thinking. But we don't have proper entire lab setup. Okay, where actual product is getting into the market, right? We don't have that market, that fabrication setup here. Okay, so it is very latest technology, the quantum computing. So it is not possible to enter into the manufacturing to see the manufacturing process of quantum. If we say reality. Okay, did you got the thing?
Yes, whether I will have a chance, like if I taking this course, what
Mhm.
will be my future perspective if I want to go into the manufacturing industry of qubit?
Yeah, yeah. First of all, this course is as of now it is not existing. It is a very future technology. It is in a research. If you are doing the MTech or PhD, if you do the research from now onwards, next in 1 or 2 years, you can involve in these type of projects in the industry. Okay, as of now, the the engineers who have very good experience in the quantum technology and atomic level, the physics, who are having the good knowledge, those are only working in the this present technology. Okay, but as a fresher, if you are looking in a future in next to 2 or 3 years, then you can do the research of these kind of technology from now onwards. Okay, so that you will get the clarity step by step. Okay, what is the initial stage and how we can move to the quantum, because these all we cannot do, a single person cannot do these techniques and all one, until unless you go with the team, you if you collaborate with some team, or going to some company, then only you can involve with these type of projects. Okay, our course main intention is, this is the future, how like not only quantum computing, neuromorphic chips is also one of the future technology in VLSI. So at least from now, if you get the idea on these technology, next 1 or 2 year, if you do some proper research in your college or in your company, you will be having a greater exposure into the maybe in future, if we have the hiring related to these technologies, then it will be helpful for you. That's the main intention. That is why the course will be helpful for you. That is how.
Okay, thank you.
Yeah. So first of all, the course is very helpful if you are really looking for some research related in VLSI. If you are looking for to learn about the future technology, the course is very helpful. Okay. So what we are going to learn exactly in this 2 months course means, first of all, we are giving the VLSI foundation and nanometer challenges for you. Okay, you already know what are the major limitations we are facing nowadays regarding the nanometer, from CMOS transistor, how the different limitations like short channel effects, or the gate tunneling effect, and there are different channel effects we are seeing in the nanometer technology. So from CMOS to FinFET, FinFET to GAFET, GAFET to MBCFET, then there are a lot of internal technologies out there. So we are going to give the foundation of VLSI, the nanometer technology and fabrication technologies. Then we are going to move with the quantum tunneling, how the gate is tunneled into the, how we are calling it as a quantum tunneling, how the electron, proton, neutron will work around the atom, because we are going to learn at atomic level in the quantum computing. Okay, till now we have stored some data through the transistors, where we use different types of transistors like CMOS or FinFET. But in quantum computing, everything will be stored in terms of electrons, in terms of that atomic level. Okay, so that that overall thing we are going to discuss in the day 1 session. And coming to the day 2, entire CMOS technologies and what are the limitations of silicon, and how the emerging technology, the quantum computing, the spintronics in the sense, what are the principles of quantum computing, what is the behavior of an electron, electron principles like superposition, entanglement principles, we are going to discuss in the day 2. And coming to the phase 2 is a quantum fundamentals, how the physics meet the devices. You already learned in engineering level and intermediate. You know the physics, how the physics is working at a quantum computing level, or atomic theory you already know, right? So by using that atomic theory, how exactly the quantum physics is going to work, we are going to discuss those things here. The quantum physics for nanoelectronics, the total atomic structure and electron states, and the quantum tunneling effects and Heisenberg uncertainty principle, these things. Okay, and next, introduction to the quantum computing. What is the difference between classical bits? If you see now the supercomputers, we use the classical bit 1, we store the bit 1, bit 0, based on the binary data we can store the data. But in quantum computing, we use the qubit. So what is meant by qubit, how the qubits are evolved? So superposition and entanglement principle. And IBM Composer, is a tool we use for this quantum. Okay, so you will be getting the access from the IBM Composer tool. We will explain you everything regarding the tool, how to work a internal tool, and how to create the different gates. Okay, how to create the superposition with the H gate. There are a lot of internal concepts. Okay, so we will be discussing everything clearly in the tool itself. Okay, and next, quantum gates. Like however we have digital logic design gates, XOR gate, NOT gate, and NAND, like that. In quantum also there will be some circuits, different type of circuits will be there. So in that X, Z, H, C NOT gates, so we are going to discuss more clearly about this. And the qubit entanglement circuit, how actually the entanglement circuit is going to work, these things we are going to discuss. And phase 3 will be the algorithms, logic and quantum. Okay, so VLSI architecture, whatever till now we have seen the classical computer architecture or supercomputer architecture, the architecture is different from the quantum architecture. Okay, totally different. So you are going to learn how the quantum circuits will be there, the VLSI architecture, and how the quantum algorithms are used in this architecture, error detection, error correction, and there will be some codes related to the surface codes. So we are going to discuss these things, and how the quantum hardware models will be written. So we are going to discuss the quantum hardware models also in VLSI platform, and how it is integrated into the SoC architecture. Quantum computing means the whole quantum computing is not different from the classical computer or supercomputer. Internal, how the processors are working, that would be different. How we are connecting different functional blocks. Okay, so that will be the different integration into the SoC architecture. And next, day 10 will be the measurement postulates, like internal how the entire architecture, there will be different techniques, the qubit control. That means qubit control means here electron will store the bit, either 0 or 1 bit. It is very difficult to control the bit there, because even there is a small temperature fluctuations are there, just small fluctuations are there, the entire system will collapse. It is not so much easy to store a data in a qubit, that too in an atomic level. So here we are going to discuss how the qubit is controlled, how the data can be controlled. Okay, so the state collapse, everything will be discussed here. Okay, and next, quantum VLSI hybrid system design phase 4. Here day 11 will be quantum VLSI architecture. So how exactly the quantum VLSI architecture will be there, the qubit control and the routing, how the quantum memories are there, the interconnects, the stack interconnects. Okay, so we are going to discuss what materials we use in the quantum VLSI. Till now in semiconductors, in chip design, till now we have used the silicon. How the silicon is made up of, we already know the carbon and the sand. Through the sand we do some heat at some temperature and we make the silicon. But for quantum technology we use different type of materials. Okay, so we are going to discuss in depth of what are the materials we are going to use, and the quantum dots, and the spintronics in the sense spin logic, how the spin logic is designed in the quantum mechanics, quantum computing, and the magnetic tunnel junctions, MGTs. Like we have different types of FETs, right? So like that, here how the artificial magnetic field is applied through the different spins to the entanglement principle and also superposition. That's what we are going to discuss. And silicon photonics, discussing about the silicon photonics. Here we will do everything in terms of lab, also hands-on. If you see here, hands-on quantum applications, whatever we learned theory, same thing we are going to apply in the IBM quantum composer. Mostly nowadays IBM is working on the quantum computer. First Google also working. IBM is mostly almost 40 to 50% is going to complete by IBM. It have internal architectures. It already designed the quantum architectures by IBM. So that's what we are going to discuss, how exactly it is doing. We will show you the videos also in the course, how internal architectures are designed, how the materials are designed in the quantum. We will show you the visual videos so that you will understand in real time how exactly it will be working. Okay, so that is what multi-qubit circuit construction. And then IBM quantum composer, there are different type of algorithms. We need to learn these algorithms, how to implement this Joza and Grover's algorithm, and also Qiskit and CIRQ, Qtip, Microsoft Q. These all are different simulation tools in quantum. Okay, so we are going to learn this IBM Qiskit and for VLSI applications, and also quantum compiler flow. Okay, coming to day 20, totally quantum machine learning in VLSI. The machine learning techniques also be involved in this quantum computing. Like if you see the QGIN's QML use cases, we are going to learn, and how the cryptography is used. Cryptography application and hardware security application we are going to discuss, and the packaging challenges, and how the quantum packaging is happening, because these all done in very clean rooms, and also the package is totally different in white boxes. we do the package. I will show you the picture. Okay, and also mostly we use the gold material through the within that white color boxes. Okay, so how the package challenges are used, like 3D stacking interconnects. Okay, and also quantum FPGA architectures. We are going to discuss this, which is a reconfigurable quantum logic, and also CPU, QPU, CPU quantum processing unit, quantum interfaces, the FPGA controllers, and last testing. After these last 5 days will be total on the project. We are actually working on some research project also in Google. Okay, so we will show you that how the industry trends will be there, the how we are working on the research project. Okay, so what is the India quantum mission nowadays? We semiconductor scheme we have from Indian government. A lot of schemes are there. So quantum mission is also one of the India's major next level mission. Okay, so to get more advanced in this technology and emerging research problems, the innovation opportunities, and the final project we are going to do with this quantum by using the IBM composer. Okay, and finally we work on the circuit simulation, debugging, and presentation. So the total simulation of the project and how to design and get the output. So finally, there will be demo sessions on this and weekly doubt discussion sessions also there. Okay, so we have designed this entire course in a 30 days. Okay, in these 30 days, mostly you will be getting the idea of from quantum, from principles, how to use the principles to till research projects. Okay, till the manufacturing process overview. We are going to give the overview. Everything will be done in the tools only. Okay, did you understood any doubts till here? Hello, am I audible?
Madam.
Yeah.
Hello. Yeah, madam, I have a small doubt. Yeah, that IBM Composer is a tool, right?
Yes.
That is industry oriented or
Yeah, it
education?
is industry oriented only.
Okay.
Actually, for quantum, we don't have the much tools.
Yeah,
Okay, if you see in VLSI or TL design and physical design, we have lot of tools. But quantum is now just it is just growing nowadays. So we will have only one or two tools. In that, IBM Composer is one of the best tool.
Okay. And one more question, madam. How can we control the bits, madam, like 0, 1? Suppose if it is flop, we can store and we can get it. But
Yeah.
in superposition or entanglement, how can we make it store or control through the
Yeah,
analog circuit or what?
we need to apply the artificial magnetic field, and we need to make it stable based on it always rotate a lot of it. It will rotate in a spin position. Okay, in
Yeah.
that spin position we are just applying the magnetic field, and we will predict how it is going to stop at one point, and it will store the data. For that purpose only we need to learn this entire course. Then only you will get to understand how we are going to store the data in the bits, quantum bits, qubits, how the
Okay.
qubits are going to work. Yeah, spin is one of the property which is we use in the superposition and also entanglement principle.
We can store completely, madam, or is there
Yeah,
any
we can
correction?
store completely. We
Okay.
can store completely, but if you see here the setup, how the setup it is nearly 0 degrees centigrade, like very
Yeah.
coolest place. Okay,
Yeah,
we
yeah.
need to store it very coolest place. Even just small vibrations are getting, the entire atom will be collapsed, because uh, the how the atom will be rotated means here, if you see It's a atom, right? We can
Yeah, yeah.
predict number of atoms. Just a second. If you see here, it's an atom. So here we are just predicting the electron. Electron is a black color. Here electron
Yeah.
will rotate around this atom, and middle there will be some neutrons and protons will be there. So first of all, why we are going to store in this electron? Because whenever we are whenever the technology is moving to 1 nanometer technology, there will be very minimal gap between the source and the drain. The
Yes.
channel will be very minimal. So easily the electron can tunnel into the gate. That is one of the property we are one of the limitation we are getting. First limitation, through that quantum tunneling, we just got the quantum theory, quantum where we can predict the electron will rotate around the atom. At that atomic level we are going to store this electron. That is the concept. Okay, so by using this electron principle, we have two principles for the electron here. One is a superposition principle, one is a entanglement principle. So by using the superposition principle, we need to make the electron at stability. We can make it as a stable, and by using the artificial magnetic field, we need to apply some more extra artificial magnetic field, which is a spin up and spin down. Based on that, we need to store the data. Spin up means 1 bit, spin down means 0 bit. This total concept is
Okay.
a very huge concept is there. One by one we need to understand. First of all, we need to understand the qubit. What is the difference between classical computer bit, normal bit 0 1, and what is the difference with the qubit? If you see, first of all, if you see what is the major importance of quantum computing means, suppose in a row there are some cards. Okay, so there are a lot of 100 number of cards out there. Okay, so in a card there is a queen and there is a joker and there are some other cards. Okay, I want to find out a joker from these 100 cards. By using the classical computer, how a joker can be picked? It will check by for every card. First card,
Yeah.
it's going to check if in the first card, if it is not available, then it will go to second card. In second card it is not available, then it go to third card. In third card it is not available, fourth, then fifth, then sixth. Like that, one by one it will be checking, which is a serial operation we can tell. Okay,
Yeah.
which is a
Yeah.
classical computer. Even if we write the code, we will write the code for same for loop or whatever the loop we take. First we will check with the one, first number, then second number, then third number, so that we can predict. But by using the quantum computing, all these cards are
Fraction of
checked
second.
by one time, within 1 second, or even less than 1 second. Just one time, at a single time it will find out a card parallelly. No
Yeah.
need to
Yeah.
check 100 number of times. That is how fast the quantum computing is working. Not only fast, it do very less operations comparatively classical computer. By using the classical or supercomputer, if we do the 100 operations here, in quantum computing just one operation is enough to find out the joker card.
And madam, one more doubt I have. Suppose we have a routing stage, right, madam?
Hmm.
Yeah, in routing stage, actually, we will make it into like unit tiles, and then between the flops, suppose if there are AND gate, two pins will be there. From the two pins, connection will be there.
Hmm.
Actually, to any logic. So that
Hmm.
logic, it suppose you have 1,000 or 2,000 tracks. Suppose
Hmm.
in quantum computing, like at a time 200 tracks it will check it, or one by one, generally in classic.
Actually, in quantum computing, we don't use normal gates, normal logic gates.
Okay.
Yeah, even though, as you told, it will check the. You are talking in a hardware level, right?
Yes, madam.
in hardware level, the quantum computing architecture is totally different from normal architecture.
Okay.
Here we don't use the memories. That setup is totally different. We use the
Yeah.
memories and all, but that setup is totally different.
Okay, but we can make it a CPU or GPU, whatever,
We
camera,
can,
every all modules.
yeah. There will be all modules.
Okay.
Yeah.
Means it's not completely related to the VLSI.
It's completely related to the VLSI. It's a upcoming technology from the VLSI only, because see, VLSI means what? It's a processor chip design architecture where it have the n number of functional blocks. There will be a processor, general purpose processor, and graphic processor, and digital signal processor will be there, multi-signal processor will be there, memory units will be there, IO blocks will be there, and different type of functional blocks like camera unit, Wi-Fi module, GSM module, Bluetooth module. There are a lot of functional blocks combined in a single chip. So even in quantum computing, without those functional blocks, how it do some operation? It cannot do some operation. Okay,
Yeah.
but architecture is different. Concept will be
Okay.
same. Architecture will be different.
Okay. Okay,
Yeah.
madam. I understood. Thank you.
See, if you see here, this setup, how the lab setup is there, this gold color, she's working with some gold, there is a gold color plates and all
Yeah.
there, right? That is nothing but the quantum computer, but it is
Yeah.
totally different from supercomputer how we are using our laptop. Okay, but
Yeah.
here in this quantum computer also there will be processor, memories, functional blocks, everything will be there, but design is different. However, we are designing normally SoC chips, that design is different, this quantum designing is different.
Okay.
Yeah.
Man, actually, whatever you told that, like for quantum computer, it should be stored nearly less than 0 degrees, right?
Yes, very
Yeah,
cold,
but
coolest
yeah,
place.
it should be in very cold places. But this will applicable in like mobile application
No,
or
no.
laptop.
Quantum computers, we never use like a supercomputers like mobile phone. We never, it never come out. It will be in some laboratory setup only. Only for major applications like military applications, like a hospitality. Only particular in laboratory setup only, these computers
Okay.
will work. Not like we can't buy. Normal peoples, we cannot
Yeah,
buy,
yeah, yeah,
we
yeah.
cannot use. These are only for specific application where we can do every like lot billions of tasks in just a second, where we can do like that. Okay,
Present, madam, like
weather
yeah.
reporting, if we see now nowadays like a flight reporting, last time we got some flight crack issue and all. We took nearly some hours to find out some issue, but by using this quantum computing, we can find out in just a second. That is what the advantage of quantum computing. Yeah, please tell.
Madam, yeah,
Let me start actually whatever I want to discuss. Then whatever the doubts you have, you can ask your
only
doubts,
one
because
doubt, madam.
yeah.
Madam, like now in India, like recruitment is happening like for quantum jobs, like related to quantum. Is there
Actually,
any jobs?
no, internal team only working on the quantum. The jobs
Okay,
are not started. Everything is in a research only. Okay, next in
okay,
1 or 2 years we will get the jobs outside. Now only IBM and Google companies are working on the quantum.
okay,
That too,
okay,
who are having a very good experience, like a 20-30 years of experience, persons only working on the quantum technology. Okay, actually our the mentor, I'm not the mentor for this entire course, another mentor is there. She already worked with the quantum technology, she already did the research paper in PhD, so that's why she is going to deal with the quantum computing the entire course.
okay, madam. Thank you.
Yeah. Okay, so
Yeah.
remaining all we are going to start our session. So if you have any doubts, you can ask. Okay. So give me let me give you a brief explanation about the quantum. I think you already got what is the importance of quantum technology, right? So first of all, what are the limitations we are facing with the current technology? Let me explain you. Okay. So you already know VLSI, nothing but the chip design, the chips wherever whatever the application whatever in your daily usage, in your day-to-day life, from morning to night. Okay. You are using your mobile phone, you are using the watch, you are using the TV, and the mobile phone charger, and also the microphones. Okay. You are going in a bus or some vehicles, everything every device have some electronic components, right? Without electronic components, there is no device. Even though it have the mechanical components or mechanical parts, internally electronic chip is also very important. Okay. If you go to health, like healthcare in the sense hospitality nowadays, if you see the hospitality, the devices, internal equipment, everything is a totally advanced, right? Even the scanning centers, if you observe, the all equipment is a total advanced technology, which where we do using the chips, electronic chips, like that automotive industry. Nowadays we are getting the self-driving cars, not in India, most of the countries we have the self-driving cars. And also in self-driving cars, if you see, the total technology is based on the chips only, the VLSI chips, the semiconductor chips we call. Okay. Where it can store the data, it will update the data, and even the driver doesn't have the brake, automatic brake system is getting just through the sensors. You just observe through the sensors, and automatic brake system is getting, like there are AC is a very oldest technology. From last 20-30 years also we have the AC in a car, like the telecommunication systems, consumer electronics, everywhere the VLSI technology is there. Okay. Normal supercomputers or mobile phones, whatever, everywhere the VLSI technology is there. Every day the technology is improving. Okay. And also jobs wise, VLSI have very good offers, high paying jobs. Okay. And in next, due to some limitations of VLSI, in next future, in next 2 or 3 years, we are going to get the artificial intelligence in VLSI. Nowadays already we have the AI in VLSI. If you see, lot of people are using the gaming devices. Yesterday also I went to the shop, Reliance digital shop. If we see the TV, latest TV technology, in that you will observe the QLED technology, QLED, QLED, and OLED laptops also there nowadays. OLED laptops also getting in that. Same this quantum only, quantum fluid technology, some quantum related technology is used there. Okay. And it already have the lot of AI features, and more advanced graphic processors from Nvidia company, and main chip, whatever the inside the TV chip is there, that inside chip is from AMD, which is the most advanced with the AI features. Okay. You just go and observe the electronic components, how electronic devices, how the newest technology is coming in a, like, you can observe mostly in the cameras, or digital TVs, or like laptops. In these only you can mostly observe, even in car. Okay. Which these are available in our surroundings. Okay. So the AI is going to involve everywhere. We are using some of the software applications like Chat GPT and DeepSeek is there. These all also work at the AI only. These all are AI. These are working because of VLSI chips. You know, in Chat GPT, the main server, the main server of Chat GPT, nearly we have used thousands of lakhs of graphic processors and central processors which are from Nvidia. company. NVIDIA is one of the topmost company in the graphic processor. It manufactures the graphic processors, right? Nowadays it is in top. Okay. So VLSI is growing very rapidly, and also we are facing lot of limitations. Those limitations we are going to overcome that, and the new technologies are also coming day by day. Okay, so new innovations also happening every day in VLSI. Okay, so there is a more need of quality VLSI engineers in the market. If you see nowadays, there are no proper quality VLSI engineer. That is true. That is true. Okay, even hiring managers know that thing, the technical managers know that thing, because there is no standard VLSI knowledge for the students. Okay, so the market is looking the proper quality of VLSI engineers. You can be a part of this revolution. If you are interested in VLSI, if you are studying BTech, just you can come into the domain with the quality of experience, like based with a good level project experience. You can crack the job very easily, and you will be getting the very high paying jobs also. Okay, next, you already know VLSI through ages, right? Can anyone explain what is meant by Moore law? Someone who didn't talk till now, can anyone explain what is meant by Moore law? Hello,
No.
please. Can you please explain, anyone?
Yeah, madam.
Other than
For
Srinivas?
every 1.5 year,
Number of transistors
transition
per
going
chip,
to increase.
Yeah, Srinivas, just someone are talking. Let them give the chance to talk others. Yeah, please, anyone.
Yes, and every 2 year
number of transistors
double.
are going to increase over the year.
Ma'am, every 18 months, semiconductors will be increasing, ma'am.
Okay, every 18 months, semiconductors are increasing.
Every
Number of
increasing, ma'am. Yes,
transistors
ma'am.
on the single silicon wafer going to be increased.
Okay. Okay.
And
Actually,
also proper
first of
duration
all,
and number of transistor exact number.
okay. Okay, fine. No problem. Actually, first of all, what is mean by VLSI? VLSI means very large scale integrated circuit. Integrated circuit means it is a IC. Here, if you see here, you already know in BTech level you have some laboratories. I think you already seen the integrated circuit. So in this integrated circuit, we will dump the architecture. What architecture we will dump? It is based on the system. There will be, if you see the computer architecture, there will be some processor, there will be some general purpose registers, special purpose registers, some arithmetic logic unit. That is basic processor. Like that, if you see system on chip design, there will be some GPU process, CPU process, memory blocks will be there, IO peripherals will be there. There are a lot of blocks involved in the system on chip design. Even if you see our mobile phone, in the mobile phone, all these different type of components will be there. If you see the motherboard, I think you heard about the motherboard in world and computers. There will be a PCB board. On PCB board there will be a CPU, RAM, processors, and PCIe ports will be there, north bridge will be there, south bridge will be there. So these all are different types of components we've just integrated on a PCB board or system on chip design. Okay, so internal these, how these components are made means based on the gates internally. Whatever the logic gates, by using the logic gates only we design a register. By using the logic gates only we design a memory. By using the logic gates only we design some IO peripheral. So by using the logic gates we just dump into the circuit. So like that, billions of logic gates, billions of transistors are integrated on a single chip. Based on that gates, billions of gates, we have got proper architecture, and that architecture is into the IC. Okay, so that is how we are telling the billions of transistors are integrated on a single chip. Okay, so if you see a olden mobile phone, there is a 2G mobile phone, and now we are using the 5G mobile phone. 2G mobile phone means small mobile phones. I think you already used in your childhood time. There will be a simple keypad will be there, key buttons, keypad will be there. Internal hardware, if you see, there will be very basic hardware. Even it have some battery and it have
Ma'am,
some
sorry to
processor.
interrupt. I have small doubt.
Yeah.
So basically, we construct. Basically, the processors construct based on combinational and sequential logic circuits.
Yes.
So is there any resource you have that any generic 8-bit CPU design which is in the form of gates, logic gates? Can I see anywhere? I tried it
Okay,
to watch. I
you want
googled
to
so
see
many
the
times.
processor. See,
In
first of all,
gates.
see,
Generic
suppose
processor, 8-bit processor.
you want to
Which
design a
is
processor.
designed.
You want to
I just
design a
want to see.
processor.
I just want to
Okay.
see any generic 8-bit CPU.
Okay.
8-bit CPU which
Okay.
is designed in gates. So
Actually, 8-bit.
logic gate symbols add NAND and
Let
NOR
me
gates.
explain. Let me explain.
Basically, I have
Actually,
hardware in the
processor. Okay. Basically, processors we have different types. X86, Intel X86. We have RISC processor. We have ARM RISC processor. Mostly
Those are
nowadays we
architectures.
architectures. Then what you need?
Okay.
Based
I'm going
on
to
the
just have a
architecture only.
basics.
See, in RISC-V architecture, we will have the different pipeline stages. Fetching, decoding will be there, execute stage will be there, memory write back will be there,
Pipeline.
register write. These pipeline stages have different hardware internal architectures. That hardware have the
very basic, simple question.
Hmm.
Going to very basics. I know how half adder executed, how full
Okay.
adder executed, how mux is working. There will be selection bits. There will be 8 inputs, 1 output. That's how I am able to see in my digital electronics, switching theory and logic design we call in some universities. There I can see the individual circuits.
Okay.
Individual combinational logic circuits, sequential circuits. How these circuits together form a processor. I just want to see in the form of gates. Not even in the form of fancy. In the form of electronic circuits also. Even I can understand even if it is if I got the circuit diagram in CMOS with CMOS transistors. But okay, apart from that, I want to see the process in the form of gates. Is there any resource? Do you know?
Okay. So you want to see the processor in terms of gate. Okay, I understood. See,
I tried to
total
see the
gate
schematic of
means
Intel 4004
okay.
but I didn't get.
Okay. In that
Is it
we will
exist?
find only we will find only the data path will be there, control path will be there, accumulator will be there, and general purpose registers and special purpose registers will be there. Some ALU will be there. This is basic processor architecture. We need to write this processor
Even in colleges also.
Mm-hmm.
Even in college also we thought we get taught combinational logic circuits, sequential logic circuits, finite state machines. But how all this together utilized and form a processor? This is the gray area still.
Okay. See,
I'm
based on
I just want to know the resource.
Okay.
Okay,
Four
I am
double
done with
zero
myself.
400 processor you are asking, right?
You don't get it right. Actually.
I got your point.
Basic.
I got your point. I got your point. You are just asking the processor internal architecture, how the gates are used. See, this is entire architecture. This is Intel 4044 internal architecture. Okay. Every accumulator have its own architecture. ALU have its own architecture. We need to write the HDL programming. From that programming, we need to get the circuit diagram, the gate level circuit diagram.
That is textual representation of same gate level logic.
Yeah, textual representation.
Not
Once we write the, see, I cannot write the program now and I cannot show you the gate level netlist, right? If you ask, if you ask, give some time, I can show you the gate level circuit netlist from the. First of all, we need to build some processor. Then only we will get some circuit netlist. Okay, I understood your doubt. You are asking the gate level circuit netlist, how the registers counters are used here. If you see here, register multiplexer, there are a lot of register, general purpose registers and special purpose registers here. First of all, we design a processor by using the assembly language program. That assembly language program will be generating some instructions. That through the instructions, every processor will work. The instructions will be fetched one by one from the memory. The fetching and decoding execution will be done in the pipeline manner, and this architecture will be involved parallelly. How the accumulator is working here, ALU getting the data, that is how internal architecture will be work. These are totally interlinked. Okay.
Yeah, I just want to know whether is there any resource. If you come to know, you will share. I thought.
Resource in the sense, see, as of now,
The gate
we
level
are not
circuits,
using,
circuit
we are not
gates.
using this. I understood. As of now, we are not using Intel 4004. We are using the RISC processor. If you ask for RISC processor, we already have the RISC 32-bit architecture. We already have. I can give you the gate level circuit netlist. If we want to have the Intel,
because 32-bit schematic is very big.
it's very complex. Then we need to develop from scratch. You can contact us. Our team already developing the RISC architecture. If you need, we can work on this processor. It's very simple actually. 4004 is very simple architecture.
I'm curious to see them. I just asking for educational purpose. I'm curious to see. If it is already available in Google, I thought you might help to help knowing. Okay, we can continue with this topic.
Okay, fine. Okay. Okay, guys. So in a process, in a architecture, the chip like integrated architecture, we are just involving the billions of transistors in it. Okay, so that's what we call as a VLSI, small scale integration, large scale integration, very large scale integration, like that. Okay, so if you observe, if you observe the 2G mobile phone and 5G mobile phone, in 2G mobile phone we will have very less hardware, and in 5G mobile phone there are lot of hardware. According to the features, every feature is included, like from 2G to 3G, 3G to 4G, 4G to 5G. So like that, lot of hardware advancements are getting into the chip. Okay, so based on that, the complexity of computer architecture is also increasing. The number of transistors also increasing every 2 years. Okay, so here we have in 2G mobile phone, just if you see, we can do only SMS, or we just do the call, or simple game we can play. But in 5G mobile phone, we got the touchpad, and we are using lot of applications. We can install the lot of apps. We are doing the multitasking, like we can do call, we can do WhatsApp at a time, we can play the games, we can listen the music. Everything is done parallelly, right? It is doing multitasking. So that core support is very important. Internal processor, there will be number of cores, so core support is also very important here. That high level architecture we are going to build in present processor or in present system on chip designs. Okay, so automatically the number of transistors will be double for every 2 years. Okay, so this whole architecture will be written into the gate level. The gate level circuit will be written into the switch level, which is a transistor level. The transistor level will be written into the stick diagrams level, where we have the stick diagrams. Okay, suppose here in small scale integration we have only 1000 of transistors in this technology, but in next medium scale we have 1 lakh of transistors, and then large scale there are 10 lakhs or 1 crore, 10 crores of transistors out there. In very large scale there will be 100 crores of transistors will be integrated. That means billions of transistors will be integrated on a single chip. Okay, so what are those transistors actually? We have different fabrication technologies, right? CMOS fabrication technology, FinFET fabrication technology. If you observe here, planar FET. Planar FET is nothing but a CMOS transistor, where we will have the source, a drain, and a gate. Okay, so till 22 nanometers we have used the CMOS transistor technology till 22. 22 nanometer is nothing but here channel width. Okay, we are calling the transistor sizes, right? 22 nanometer, 14 nanometer. Current technology, current mobile phones, we are using 3 nanometer technology. So this size is nothing but where we calculate through the channel width. Channel width we call as a size. Okay, so from in planar FET, in CMOS FET, after just a second. Okay, so in this planar FET, we have the lot of limitations. Once day by day the transistor size is reducing. Okay, so according to the Moore law, the number of transistors are integrating on a single chip will be double. That means number of transistors are increasing day by day. At the same time, the size of the transistor is reducing. The size of the transistor is reducing, right? I think you already know this point. Okay, so if anyone is not able to understand the concept, what is meant by fabrication technology, the CMOS and all, if you don't understand, in our YouTube channel, ProV Logic channel, we already have the clear explanation about the Moore's law and these planar FET, FinFET, GAFET, all these concepts are already there. What is meant by small scale integration, how the number of transistors are integrated on a single chip, everything is clearly mentioned. Okay, you can just go through that, because this concept is a moreover quantum computing concept, like what is the limitation of VLSI and how we are moving to the quantum computing. Okay, so if you don't have the basic idea, just you can go through that once, and if you have any doubts you can contact to us. Okay, so next, if you see, because of the limitation of CMOS transistor, what are the limitations? Short channel effects and the gate tunneling effects once it go to the 22 nanometer. However, the current flow is happen between the source and the drain. So because of this conducting material, two conducting materials are very near, we will get the current loss. There will be some leakage effects will be there, and the channel effects will be there. So from that we move to the FinFET. FinFET is also same technology like a CMOS FET, but the connection, the way of connection, if you observe how the PMOS and NMOS are connected here, planar manner, but in a FinFET manner it is connected like a vertically. In a planar FET, which is nothing but CMOS FET, it is connected in a horizontally, but in FinFET these PMOS and NMOS are connected in a vertically and divided into the two vertical lines like this here. Okay, so based on that there will be more controllability between the gate and the source and drain, so that we can avoid the short channel effects here. Okay, but after in FinFET also, after it is reducing to 14 nanometer technology, still we got the same issues again, same issues are raised. Okay, so again we move to the GAFET. GAFET means gate all around. If you see here, well, here how the well is taken, and here the GAFET, how the well is taken here, the difference between GAFET. So how the PMOSFET and the well is divided here. So based on that, the GAFET is introduced. Still in GAFET also, after reducing to 7 nanometer technology, we faced the limitations again, the short channel effects and the current leakage effects, or these limitations we already faced. Okay, so CFE FET, CFE FET is introduced from GAFET to this technology, how the PMOS and NMOS are connected, if you can observe. Okay, so based on these limitations, currently we are in a 3 nanometer transistor technology. In next 3 to 4 years, or in next 5 years, anyway we will reach to 1 nanometer technology. Okay, so what happens after 1 nanometer technology? There will be very minimum distance between source and the drain. Till now, based on the transistor, if transistor is on, we have stored the 1 bit. If transistor is off, stored the 0 bit. But the transistor moved to the 0 nanometer technology, then the transistor doesn't work. It doesn't work as a the transistor properties doesn't work. It cannot do the switching operation. It cannot do the 0 1 like that. Okay, so what is the latest technology we are having? That's what our point. Any idea? Hello. Hello. Yeah, am I audible?
Yeah, madam. Can you repeat the question, madam?
Repeat the question, please.
I am asking the question like, till now, if you see CMOS FET transistor means it's up to 28 nanometer. FinFET from 28 nanometer to we move to the FinFET transistor 14 nanometer. Then GAFET 7 nanometer. And then here MBC FET is there. There are a lot of technologies. Now from 100 nanometer, 24 nanometer, 14 nanometer, 7 nanometer to now we are in 3 nanometer technology. Okay, and that too we are facing lot of limitations here. After next 3 to 4 years, we will come to the we will reach to the 0 nanometer technology also. At that time, how we can store the data in a transistor, how the circuit will work? That's what my question.
Circuit wise same.
That time transistor doesn't work as a switching operations. It doesn't work with the properties, right? It cannot store the 0 or 1. So how the technology will be changed? Will VLSI dead at that point? Then what about the future chip design? Actually, for that reason, we have launched this course. Actually, at 0 nanometer technology, we cannot store any data in the transistors in VLSI. Okay, so the chip design will be still not existed. Okay, so what happening in the beyond 3 nanometer technology, and what is the future technology in VLSI at 0 nanometer technology? How we are going to store the data? Suppose there will be only very few electrons will be there. We need to predict the electron at atomic level, and we need to store the data at atomic level. Okay, so that is what the technology we are calling as a quantum computing. But before quantum computing, we have different technologies like neuromorphic chips, quantum VLSI chips is there, 3D IC and heterogeneous integration is there, photonic chips, the spintronics. There are a lot of VLSI future technologies are there. In that, one is very famous one, neuromorphic chip. Neuromorphic chips also, the currently the research is going on. Neuromorphic is nothing but how the brain is how our human brain is having some structure, right? The human brain is nothing but the CPU. how the processor is working. But in supercomputers, the processor is working based on the instructions, right? Based on number of instructions it generate, and it will just do the different number of tasks. However, our brain is generating different type of instructions. If we do some task, if we talk something, or if we do any other task, it totally depends on our instructions from the brain, right? So same human, however the neural structure is there, same structure is introduced here in neuromorphic computing based on the deep learning and machine learning techniques. This is one of the technology we have, and quantum computing is one of the best technologies going to evolve in the next 2 to 3 years. Okay, so for that purpose we have introduced this quantum computing course. Okay, so more details we are going to discuss in the course. The main course is going to start from this weekend onwards, this next week onwards. Okay, so if you are interested to know more about the quantum computing, how the data is going to store in an electron once the chip is reduced to 1 nanometer, 0 nanometer technology, and based on the electron principles, how the quantum computing is working, and how we can stabilize the electron in the temperature fluctuations, how the spin is used to store the data, and how the artificial magnetic field is integrated to the spin in superposition theorem and entanglement principle, how these both principles are working to store data. The qubits, how the qubits are different from the normal classical bits. If you want to store, if you want to learn all the things, and if you want to work with the real time tools and all, you can take the training. Okay, you can take the course, or if you are not interested for the training, you can do research from your side. But the main what is the benefit from the training means there will be regular live sessions. Who are doing the research in this particular quantum computing, those mentors is going to deal this entire course. Okay, so you will be getting the mentorship from the PhD members who are working in real time, who are doing research, and also you will be getting the tools and also project level. If you are a fresher or if you are a working professional, if you are looking for the best job, next job change, if you put this type of technology in your resume, you will be getting the chances for the latest technology interviews. Okay, in job description they will mention, right? So those type of jobs you can apply. Even you can, if you are studying still BTech, uh, uh, if you are studying the BTech, you can apply for the IIT Delhi is working nowadays on quantum technology. You can apply for the internships. You will get the best internships from these top 2 companies. You can try in that way. Okay, one of the best VLSI technology in the future where we are going to use. Okay, so that is why we have introduced now. This course will be best for the college students if you are interested to learn more depth. Okay, any other doubts?
Hi, Prashanti.
Small.
Hi.
What would be the role of quantum computing in front end or back end?
See, we don't have particular roles for this quantum.
I mean, role
Just
means like impact. I mean, how it will be for the current technologies, how the quantum computing will replace it.
PD people or VLSI DV people also can take this course. They can do research. See, first of all, you can check in any job description. We will not have these not in regular posts. In regular posts, we don't have this in job description. Okay, so whenever particular sometimes yearly once or twice we will get the internships. and particular job release we will get, okay, in direct sites. That time, based on the requirement, whether VLSI DV engineer or PD engineer can apply. Both are eligible for this. PD engineer means that is more beneficial, but even DV engineer also you can explore. That's not a problem if you have interest.
Then, I mean, what will be the difference between the current design verification front end and the futuristic quantum computing concepts? I mean,
See, design verification, whatever we are doing now, it never replaced by quantum computing. That is different technology, and currently whatever we are doing, that is different. It never replaced with the quantum. Okay, did you got my point?
yeah,
You got your answer?
yes, Prashant. Thank you.
Okay. What about others?
Hello, ma'am. Am I audible?
Yes, yes.
Ma'am, my question is a bit generic. Actually, I'm pursuing my research in quantum technologies only. So, like on days, it won't be possible for me to attend the meeting. So, will the recordings be available?
Yeah. Recorded sessions are available.
Okay, thank you.
So guys, if you have any doubts, you can ask. Okay, so you can call to us if you have any doubts. So this course is going to start from next week onwards, but this is very best course for research purpose. Even you are in a VLSI DV domain or a PD domain, this is more advanced course. You can learn more advanced future technologies. Okay, next to 2 to 3 years, mostly we will get the open sources for this, but as of now we don't have much open sources. We are getting from the industries only, from the trainers. Okay, so better you can do the research. This is just like a part of your job or part of your academics. Okay, so in future whenever we have the good requirements, so first preference would be yours, like you can apply easily because you will be having already good experience in this, right? So if you want to learn beyond the technology, this is very best. Okay. Is there any other doubts?
Yeah, hi. Am I
Yeah,
audible?
please. Yes.
Yeah, how was the placements right now for a back-end engineer for a fresher as of now?
Which year passed out you all?
2024.
24.
Yeah.
24. Actually, for 25, there are internship opportunities.
Okay.
For 24, we have less only.
Okay, actually I'm seeing in LinkedIn whether on social media there is no openings for freshers as of now.
Okay.
Many are asking minimum 2022 passed out students for then if I join
22 and 23. Yeah, till 23 there are openings.
yes, I am
It depends. If you're doing the training from the institution, you can get from there, because nowadays what happening means outside there will be no recruitment. One thing is one or two recruitment is going to the college and or to the institutions.
okay.
Yeah.
But actually I will tell the truth to you. I have completed my PD training course from Sumeda IT. You may have idea about it.
Yes.
Yeah, but right now I completed my course. Even after 1 month, we didn't get any opportunities for us. Actually, we have got some companies.